Okay, possible rational zeros, we use the rational root theorem, p over q. So p could be factors of the constant, and q are factors of the leading coefficient, the coefficient of the variable to the highest exponent. Okay, so now we need to make all possible values of p over q. Okay, so I'll try to do it in a systematic order so I don't skip any. So for both numerators, I could have a denominator of 1, which I don't need to write. And for both numerators, I could have a denominator of 2. And then for both numerators, I could have a denominator of 4. Okay, factored form. So first zero's at -1. So that creates a x minus -1, or really just x plus 1. And because this graph wiggles through, I know that this is cubed. Okay, then over here, it's at 0, so x minus 0 is just x. And this one goes straight through, so it'll be to the first power. And then here, this is a root at +2, so x minus 2 is a factor. And this one bounces off, so this is squared. Okay, and then, so far I've got x plus 1 cubed, and x minus 2 squared. But then I need to keep in mind the end behavior. So this function, so remember this is x to the first, this has degree 1 plus 3 is 4 plus 2 is 6 total, so this is even degree. And I know that like x squared, a basic even degree quadratic, would have end behavior pointing up at both ends, but this one points down at both ends, so this must be negative. Okay, find all the roots given x plus 1 is a factor. So if x plus 1 is a factor, that means that -1 is a root. So let me do the synthetic division to factor. Okay, take all the leading coefficients. If I had skipped any, I would have put a 0, but we hit every single exponent in order. Okay, when we go down, we add. When we go diagonally, we multiply. Okay, remainder is 0, so that verifies that x plus 1 is a factor. Okay, so now I need to divide into this. Okay, so, well, again, we could use the rational root theorem to list out our possibilities. So it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Okay, so I do need to try -1 again, even though it already worked once, because it has the possibility of having multiplicity more than 1. Okay, so I'll try -1 into the remaining polynomial. So again, I can ignore the remainder now. Okay, so this time the remainder is not 0, so -1 did not work a second time. Okay, so I go back to the polynomial. Okay, and let me try a different factor. How about -2? Okay, so -2 does work, but again, I do need to try again. Well, actually, at this point, the remaining polynomial is a quadratic, because here's the remainder, so this is the constant, this is the x to the first power, and this is the x to the second power. So now, instead of doing guess and check with synthetic division, I can just factor. Okay, so it looks like 3 is also a root with multiplicity 2. So I had -1 as a root, I had -2 as a root, and I have positive 3 multiplicity 2. Okay, what are the asymptotes and or wholes? So let's factor this. Numerator, and then denominator. So let's see, it's got to multiply to -3, and then add to 1. So I want the positive to be greater. Okay, so right now I could do my excluded values, setting both the denominator equal to 0. So if 2x plus 3 equals 0, then the whole denominator becomes 0. So if x is -2/3, excuse me, -3/2, but then also if x is +1, this becomes 0, making the whole thing 0. Okay, so excluded values can become both vertical asymptotes and wholes. So here we notice that the x minus 1 factor can be reduced. So that means that the excluded value of 1 is going to create a whole, not a vertical asymptote. Okay, so how do I get the y coordinate? I substitute 1 back into the reduced version. So 1 minus 4 is -3. 2 times 1 is 2, plus 3 is 5. Okay, so there's the whole. So this value of -3/2 does not get reduced away, so that becomes a vertical asymptote. And it's a line, so we want to write it as an equation. And then finally, horizontal asymptote. Numerator and denominator both have degree 2, so we just compare the leading coefficients. So numerator is 1, denominator is 2. Okay, so here we got to get a common denominator. So let me just copy it down first. Okay, and I'll go ahead and factor this one over here. I can factor out the GCF of 4. Okay, so now it's much easier for me to see what each denominator is missing. This denominator is missing a 4, so I'll multiply by 4/4. This denominator is missing the x plus 3, so I'll multiply by x plus 3 over x plus 3. And this denominator already has everything. Okay, so I'll continue over here. 2x times 4 is 8x. Okay, and where I would say the majority of mistakes happen is not distributing this minus sign. So -1 times x is minus x, but then -1 times +3 is now -3. And this equals the numerator over here. Again, once we have a common denominator, we can just focus on the numerators. Okay, so we've got 7x minus 3 equals 5x plus 3. That means that 2x equals 6, or x equals 3. And again, if you're not sure this is correct, you can always plug this back in to the original equation. Here we got to use the work formula. Okay, the unknown is the time together, so I'll call that t. It takes Tom 4 hours, it takes Huck 5 hours, and it equals 1. Okay, so again, common denominator. Okay, so this becomes 5t plus 4t all over 20 equals 1. So 9t over 20 equals 1. And then I'll multiply by the reciprocal. Okay, so together it would take them 20 over 9 hours. Okay, to simplify a complex number, we need to use the conjugate. So the conjugate is the denominator with the middle symbol switched. And we have to be careful to distribute here, so I'm going to put parentheses in. Okay, so let's see, in the numerator, we have 15 plus 6i plus 5i plus 2i squared. Okay, so 2i squared is -1, so 2 times -1 becomes -2. And then we have 15 minus 2 is 13, 6i plus 5i is 11i. So that's all for the numerator. Now the denominator. Okay, we got 25 plus 10i minus 10i minus 4i squared. Okay, so again, the point of the conjugate is to make these cancel out. And then -4 times I squared becomes -4 times -1 becomes +4. So 25 plus 4 is 29. Okay, so we are going to want to square both sides to get the x out of the radical, but we don't want to do it yet because there's other stuff with it. So first subtract 3. Or we don't even want to divide by 2 first because that would create a decimal. Okay, now we can divide by 2. Okay, now that the radical is by itself on one side of the equation, we can square. Okay, so for this one, both radicals are by themselves, so we can skip straight to the squaring. Oh, sorry, back over here, we should always check with radicals because extraneous solutions can happen. Okay, so now over here, we square both sides. That simply gets rid of both radicals. Okay, subtract x from both sides, subtract 5 from both sides. Okay, let's see if this is a real solution or if it's extraneous. Okay, so both sides are equal, and neither side is radical of a denominator, oh sorry, radical of a negative, so we're fine. Combine to a single logarithm. So first we could use the power property. Okay, so now to combine two logs with the same base that are getting added, you multiply their arguments. So x cubed times 4 is 4x cubed. Okay, now let's bring in that last term. To subtract two logarithms with the same base, you divide their arguments. Okay, there's a couple different ways you can solve this one. One way is you could take the log of both sides. Okay, now we apply that power property to move the exponent of x out in front as a coefficient. Now that the x is multiplying this constant of log base 7, we divide both sides by log base 7. Or sorry, not log base 7, log 7. Okay, so this is equivalent to log base 7 of 4, and it's also equivalent to natural log of 4 over natural log of 7. Okay, solve for x. So I need to get the x out of this natural log, and the inverse operation of natural log is exponentiating with a base of e. So I make both sides exponents of the same base, in this case e. So I choose e because e is the inverse of natural log, so that gets the exponent out. And now just subtract 3 from both sides. Okay, coterminal angles. Remember, like if you just keep winding around the circle, you end up in the same places. So every full circle in radians is worth 2 pi. So if you add 2 pi and just get a common denominator, that'll give you a coterminal angle. Or you could also subtract 2 pi to get another coterminal angle. Okay, so we know our angles always start on the positive x-axis, and then now we're saying it goes through 12, 5. Okay, so if we draw in a little right triangle here, the 12 represents the adjacent leg, and the 5 represents the opposite leg. So tangent of theta is simply 5 over 12. Okay, write a sine function. Okay, so first, where's the midline? Halfway between the minimums and maximums. Okay, midline's at +1. Okay, next, how about the amplitude? From the midline, the relative maximums are 3 units up. Okay, how about the period? So it takes, from 0 to 4 pi, it takes 4 pi units to get through one period. And we know that for sine, the period is 2 pi over b. And in this case, that becomes 4 pi. Okay, so let's get the b by itself. Okay, b is a half. So b is the coefficient of x. Okay, and there's no phase shift because sine starts at its midline heading upwards, and that's what happens here. Okay, solve for a below. Okay, so there's a couple of different ways we could do this one. One method is we could use the law of sines. We have enough information to do that. Okay, we know a triangle adds up to 180 degrees. So take away 33 degrees, and then take away another 85 degrees. Okay, so I'll leave 62 degrees over here. So now that we can apply the law of sines, sine of a over a equals sine of b over b. Okay, so angle A is 33 degrees. Lowercase a is our unknown. Sine of angle B over side B. Okay, and now we cross multiply and solve for A. Okay, and then using our calculator, this turns out to be approximately 3.7. Okay, so vertex form of a parabola that opens up and down. Okay, so the vertex is hk. In this case, h is 4, k is -3. Okay, and how do I know it opens up and down? Because it's simply y, but there's an x squared term. Okay, so vertex is 4, -3. And because a is positive, it's +2, I know it opens upward. Okay, and they want the axis of symmetry, which I know goes through the vertex always. So this is the x coordinate of the vertex, so x equals 4. Okay, center and radius, we're gonna have to complete the square. So first, let's get the x terms and the y terms together. Okay, so my goal is to make this look like that. So half of -4 is -2, but then I know that to create this perfect square binomial, I have to do -2 squared, which creates an extra +4, which I have to do equally to both sides. And then similarly with the y's, this is my goal. Half of +2 is +1. And then, well, 1 squared means I had an extra +1. Okay, so the formula for a circle is this. Okay, so center is hk. So in this case, that's 2, and this is y minus -1. And then r squared is 5. So the radius is r. So if r squared equals 5, r equals radical 5. Okay, vertices of, so this is an ellipse because they're both positive, the x squared and the y squared, but they have different coefficients. Okay, so center, well, the general formula. Okay, so just remember a squared and b squared depend on which one is bigger. So in this case, the center is 2, -1. Okay, so the y denominator is 9, so that'll be a squared in this case. So we switch these. Okay, so if a squared equals 9, then a equals 3. So from the center, I go up 3 units and down 3 units. Okay, and down 3 units. Okay, so that's actually all we needed to answer this question. These are the vertices. The co-vertices would come from here. So if b squared is 4, then b is 2, so 2 units left, and 2 units right. Okay, but these are the vertices, right, the longer direction. Okay, and then what are the foci? So this is a hyperbola. I know that because x squared and y squared have different signs. Okay, so let's see. So minus. Okay, so this one opens left and right because the x squared is positive. The center is at 3, 0. Okay, so the foci follow the formula. Well, we need c squared, which is a squared plus b squared. Okay, so remember for the hyperbola, the foci lie outside. So a squared is 4, b squared is 5. Okay, so c is 3. And again, because the x squared is positive, I know that the hyperbola goes left and right, not up and down. Okay, so that means the foci would also go left and right. So from the center, I go 3 units to the right and 3 units to the left. Okay, solve for x. So we want to get the absolute value by itself. Okay, so absolute value means the inside could either equal positive 4.5 itself, or it could equal negative 4.5, and then the absolute value will switch it to positive 4.5. So we just solve both of these and get 2 different values for x. Okay, write a function which fits this table. Well, I noticed that all the values have a constant multiplicative rate of change of times 3, so it's exponential. Okay, so let's just check. 3 to the 0th power is 1, 3 to the first power is 3, 3 to the second power is 9. Okay, write a function which fits this graph. So this is a single straight line, so it's linear. So we want to look for points which have integer coordinates. So here's a point, -1, 2, and here's another point, 2, 1, and here's a third point. We don't need a third point, but here it is. Okay, so why don't I use these 2 values? So first I want to get the slope. Okay, so that would be 0 minus 1 over 5 minus 2. Okay, so slope is negative 1/3. And I know that slope-intercept form looks like this. Okay, so let's just plug in a point now for x. So why don't I just use 5, 0. So when x is 5, y should be 0. Okay, so this will let me solve for b. So 0 equals negative 5/3 plus b. So then b must be positive 5/3, making the full equation y equals negative 1/3 x plus 5/3. Okay, so finally, shoe sizes, mean of 10, standard deviation 1.5. Okay, and I want to know what percent of men have shoe sizes larger than 13. Okay, so what percent is more than 2 standard deviations above the mean, right? That's what 13 is. So I know from the empirical rule that, well, using symmetry first of all, this left half of the graph is 50%. Okay, so how much is this little chunk? Well, I know that from mu minus 2 sigma to mu plus 2 sigma is 95%. So then, using symmetry, half of that would be 47.5%. Okay, so from here to here is 47.5, and then the other half is 50. So that's a total of 97.5% to the left, but I want the area to the right, so I subtract from 100, and I get 2.5%. Okay, so survey of 36 chefs. Average is 4. Given the standard deviation, find the confidence interval. Okay, so 95%, so z star is 1.96 times the standard deviation over the square root of the sample size. Okay, so, and then the actual interval. Okay, you could also approximate this with the empirical rule, because 95% is our common number. We know that 95% is 2 standard deviations above and below. But remember, we don't use the population standard deviation. We would use the sample. So we would have to do 0.8 divided by the square root of n. Okay, and then again, we know that the confidence interval for 95% is 2 standard deviations above and 2 standard deviations below. So we could say for plus 2 times that, or for minus 2 times that, and it turns out to be exactly the same thing in this case. Okay, simulate an event with probability 75%. Well, that's simply 3 out of 4. So if you wanted to roll a die, okay, we need a denominator 4, so we got to throw out 2 of the sides. So we could say 5 and 6 are re-roll. So we want 3 options to be successes. So then 1 choice should be a failure. Okay, that's 1 option. You could also draw a card. So there's 4 suits in a deck, so you can make 3 of them a success. could make the last suit a fail. You could also use a random number generator. Okay, so 3 out of 4, that's equivalent to 6 out of 8. So we might say if there were 8 numbers, so if it were, how about 1, 2, 3, 4, 5, and 6 are considered a success. 7 and 8 would be considered a failure. And then, well, if we had 0, then, right, because that means 6 out of these 8 options are failures.